This is Abranjani from Computer Science Department. Today I'm going to tell about the topic Basic Network Architecture, the of OSI, that is OSI reference model in computer network. So by end of the session, you will able to understand what is meant by the OSI reference model. So first we will see what is meant by OSI reference model. So here the OSI reference model, this is a model based upon the proposal developed by the International Standard Organization ISO as a first step towards the international standardization of the protocols used in the various layers. Here, the model is also called the ISO or the OSI, that is Open System Interconnections Reference Model, because it deals with the connecting open systems, that is the systems that are open for the communication with other systems. The OSI model is going to have the 7 layers. So here the open system interconnections, here in this, the n number of users who uses the computer network are located over the world. To ensure the national and the worldwide data communication must be done easily. To make the system compatible and communicate with each other, so the International Standard Organization of Standard has developed a standard so that the standard is called as an OSI reference model. So here an OSI reference model, it's also called as a 7 layer architecture. The design principles of the OSI reference model we are going to see as a layer should be created where a different abstraction is needed. Each layer should perform a well-defined function. The function of each layer should be chosen within an eye toward defining internationally standardized protocols. A layered boundary should be chosen to minimize the information flow across the interfaces. A number of layers should be large and enough that distinct functions need not to be thrown together in a same layer or out of a necessity, and small enough that architecture should not become it unwidely. Here, the as we have seen, we can see here, and we are going to have a different layer. Number of layers should not be large or should not be small. Next, we are going to have the protocols and standards. Then the protocols, that is in computer networks, communication occurs between entities in a different systems. An entity is anything capable of sending or receiving information. However, two entities cannot simply send bit streams to each other and expect to be understood. So here, for communication to occur, the entities must agree and on protocol. The protocol is a set of rules that govern different communications. A protocol defines what is communicated and how is communicated and when it is communicated. The key elements of protocol are syntax, semantics, and timings. The syntax, it is nothing but the term syntax refers to a structure of a format of the idea, meaning the order in which they are presented. For example, a simple protocol might expect the first 8 bits of data to the address of the sender and the second 8 bits of the address to the receiver and rest of the stream of the messages itself. Next here, the semantic. The word semantic refers to the meaning of each section of bits and how is the particular pattern to be interpreted and what action is to be taken based on the interpretation. Timing. The term terming refers to two characteristics when data should be sent and how fast they can be sent. Next, the standard. The standards are essential in creating and maintaining an open and competitive market for equipment manufacturers and in guaranteeing the national and international interoperability of data and telecommunication technologies and processes. Next here, the standards provide guidelines to manufacturers, vendors, governments, agencies, and other service providers to ensure the kind of interconnectivity necessary in today's marketplace and as well as international communications. Next, we can see the OSI layer. That is, here we can see the OSI reference model. The first layer we are going to see, at the bottom we are going to have a host A and host B. We can call it as the computers also, sender and receiver, anything, client or server. The next one here, first thing is a physical layer. The next one is data link layer. Next one is network. Fourth one is transport. Fifth one is session layer. Sixth one is presentation layer. And seventh one is application layer. The same type of layers will be present from both the sides. So now we will see it has a OSI model has a 7 layers, that is from 1 to 7. Here two hosts are there as I tell you earlier. The host may be two computers, that is one client and other is server. Or we can say both are clients or both are servers. Sometimes it acts as a sender or receiver. Each system has a 7 layers and host A 7 layer and host B 7 layer. The communication between these layers is called as a protocols. The protocols is nothing but a set of functions that we have to be implemented. First, we will see one by one layer, that is a physical layer. The physical layer coordinates the functions required to transmit a bit stream over a physical medium. The physical layer is concerned with the following, that is the physical characteristics or interface and a medium. The physical layer defines the characteristics of interface between the devices and transmission medium. Next, the representation of bits. To transmit the stream of bits, it must be encoded to signals. The physical layer defines the type of encoding. The data rate or transmission rate, the number of bits sent each second, is also defined by the physical layer. Synchronization of bit. The sender and receiver must be synchronized at a bit level. The clocks must be synchronized. The next one we can see in a physical layer, it is a line configuration. In a point-to-point configuration, the two devices has been connected to the other through a dedicated link. In a multiple point configuration, a link is shared between the several devices. Next, in physical layer, we're going to have a physical topology. That is, we have seen in a topology. The physical topology defines how devices are connected to make a network. The devices can be connected using a mesh, bus, star, or ring topology. Next one, we are going to have a transmission mode. That is, the physical layer also defines the direction of a transmission between two devices. That is a simplex, half duplex, and as well as a full duplex. As we can see in this, the physical layer, the data will be transmitted in a form of a bits. That is also the bits in a pattern of 0 and 1. What the data information has been sent from the data link from the sender side, the same data will be received through a transmission medium to the receiver side. As we can see in the physical layer, it is the first layer of data link layer. As I told you earlier, physical layer, each thing will be in a form of a bits, and the number of unit exchange in this physical layer is a bit in a form of a 1, zeros and ones. And other things we can see in a physical layer, it is a bit synchronization, bit control, physical topology, transmission mode, everything will be present. And electric signals will be transmitted to the sender, as well as data encoding is also done in this layer. And hub, repeaters, modems, cables, and all are present in the physical layer devices. Next, we can going to see is the data link layer. The data link layer is responsible for transmitting frames from one node to a next node. As I told you, in a physical layer, the data will be transmitted in a form of a bits, whereas in data link layer, the data will be transmitted in a form of a frames. The other responsibilities of this layer are framing, that is, divide the stream of bits received into data units called as a frames. Physical layer addressing, if a frames are to be distributed to a different systems on a network, the data link layer adds a header to the frame to define the sender and receiver. Next is flow control. If the rate at which data are observed by the receiver is less than the produced rate produced in the sender, the data link layer imposes a flow control mechanism. Error control used for detecting, retransmitting damaged or lost frames and to prevent duplication of frames. This is achieved through a trailer added at the end of a frame. Access control, it is a main used to determine which device has control over the link at any given time. Next, we can see in this from the network layer to the network layer, the data will be transferred in a form of a frames, and it is a responsible for node-to-node delivery of messages, and it has to check data transfer is error-free. The packet received from the network in further divided into frames depending upon the size of the frames, that is a network interface card. Next here, the frame buffer is full of stop and transmitting signals. We can see that you're going to hear the devices like switches and bridges, and which are we use it for transmitting of the data. The next thing we are going to see here is the network layer. It is mainly required when it is necessary to send information from one network to another network. The other responsibilities of this layer is a logical addressing. If a packet passes the network boundary, we need another addressing system for the source and destination called logical address. Next one is routing. The devices which connect various networks called routers are responsible for delivering packets to its final destination. So here in the network layer, it mainly uses for the controls operations of the subnets. The routing packets from the source to destination, it's going to select the shortest path to be for the transmission of packets from one number of routers is available. The IP header has to be placed in a network layer. If you know the IP address of the receiver, the data can be sent easily. Next is the main functions in it is routing as well as the logical addressing, as we can see. Here in the transport layer, the data will be transmitted in a form of a data, that is in a form of a packet. We can see here the data has been transmitting from the one system to the another system. Next thing we have here is the transport layer. It is responsible for process to process delivery. It also ensures whether the message arrives in order or not. The port addressing, the header in which must therefore include an address called a port address. This layer gets the entire message to correct process on that computer. Next one is segmentation and reassembly. The message is divided into segments, and each segment is assigned a sequence number. These numbers are arranged correctly on the arrival side by this layer. Connection control. This can either be connectionless or connection oriented. The connectionless treats each segment as an individual packet and delivers to your destination. The connection oriented makes a connection on the destination side before the delivery, and after the delivery, the termination will be terminated. Flow and control, similar of data link layer, but a process to process takes place. In the session layer, we can see the data will be transferred from one layer to the another layer with the help of this diagram. Next thing we have here in the session layer is the session layer establish, manages, terminates connection between the application. The other responsibilities of this layer are dialog control. These sessions allow two systems to enter into dialogue either in a half duplex or full duplex. Next one is synchronization. This allows to add checkpoints into a stream of a data. Next, we have here presentation layer. And whereas in the we can see in the session layer, some of the things like it's main the thing is synchronization, synchronize the conversation between two applications. Next, it is a session establishment, maintenance, termination, and as well as synchronizing data. And as a dialog controller, that is a session layer determines which device communicate first and amount of the data to be sent. Next one we have a other one is a presentation layer. It is concerned with the syntax and semantics of the information exchanged between the two systems. The other responsibilities of this layer is translation, that is different computers use different encoding system. This layer is responsible for interoperability between these different encoding methods. It will change the message into some common format. Next one is encryption and decryption. It means the sender transforms the original information to another form and sends the resulting message over the network and vice versa. Next, compression and expansion. The compression reduces the number of bits contained in the information, particularly in a text, audio, and video. As we can see here, the data will be transmitted from the application layer to the session layer, and from session layer to the application layer to the other side. So, this is the we can see in this presentation layer. Sorry, in presentation layer, we have some of the functions like translation, ASCII to FB, CD, IC. Next, encryption, decryption will be there. If you want to, if I have sent a message, for example, I have sent message in a Telugu from sender side, the receiver know only English. Then with the help of this presentation layer, the data will be encrypted. It will translate the language which the receiver want to know. Next, the compression, that is the number of bits will be reduced. Next one is application layer. In application layer, it is known as the topmost layer of the OS layer. This layer enables the user to access the network. This allows the users to log on onto a remote. The other responsibilities of this layer are FTAM, that is file transfer access, and GMT, allow the user to access files in a remote host, mail services, provide email forwarding and storage, directory services, provide database source to access information about various sources and objects. Next thing we are going to have in this is how the user is sending some message. It will first go to the presentation layer. Again, from presentation layer, it goes to the user side. And this is known as the topmost layer of a OSI model, and as well as it is a layer through which we can user can interact. It provides services to the user. The application layer program is based upon the client server mode. And the functionalities of this layer, it is an identify communication partner, that is to transmit the data, determine resource availability, checks whether the sufficient network resources are available for required communication, synchronize communication, that is provide cooperation, which is mandatory by required. These are the things we can see in this layer. These are the layers we have discussed, and as well as these are sample questions and long answers come from this topic. I hope you have understood. Thank you.